Hello friends, today we will discuss on the topic of scale-up calculations. There are so many calculations, but out of that we will stick to the topic of only agitator power calculation. In pharma industry, tech transfer activities are common. Either that will be for the new product, technology transfer, scale ups, scale downs, and sometimes it is the cost improvisation projects. In that case also you have to change the facility, equipments and all. Sometimes new facility creations are there also we have to transfer the existing product. In that, a reactor is a most important equipment because it is used for the reaction, extraction, distillation and the crystallization operation. Now, why agitator power calculations are needed? That is the basic question. For anything to happen, either reaction is governed by the mixing, means the collision. If number of collisions are more, then reaction will happen faster. But it is not a proven law that each and every time we should have the fastest mixing. Fastest mixing, sometime it will help, but sometime it will go wrong. Some side reactions may happen faster. If we are keeping lesser mixing, then also sometime reaction rate may drop down or side impurities may also form. So that situation is not fixed each and every time. So the mixing intensity as per the kilo lab we should have to keep, and for this purpose we should have that value of a mixing. And to have that value of mixing, there are so many parameters that need to be calculated. Out of that, agitator power is one of the parameter that will help for the matching a agitator power, and that we have to match with a kilo lab data when you are transferring that product to the plant level. So how it is calculated, what is the formula, which are the terms, which are the considerations, and along with one example I will tell you this. For this we can move to the website, the pharmamaster.com. In that, go to the technology, then batch reactor, okay. So see, the formula for the agitator power calculation is this, where n means number of stages of the agitator. In reactor, you have seen there are multiple stages of the reactor. For the bottom side, one agitator is there. Then at the middle side also one agitator. Sometime it will be one stage, two stage, or three stage. So we should have to calculate for each stage power, and then we have to do the summation of it. So this is for our single stage. Then we have to use value n as 1. Now np is a power number. and that NP is depend upon a agitator type. For anchor, NP is different. For propeller, NP is different. For turbine, NP is different. So that NP you have to take. Then N is the rotation RPM that we have to take in the RPS. Then D is the sweep diameter. N is the RPM, already I have explained, and rho is the density. Formula is NP rho n raised to 3 d raised to 5. This is the formula. If you put the values over here, then we can get the power in watt. So for the understanding purpose, I will take one example. See the example over here. Agitator is an anchor which is running at 75 rpm. Sweep dia of agitator is 1.2 meter. Viscosity is given 1.2 kg per m meter second, and density is 1000 kg per meter cube. Now we have to put all the values. So N is 1, single stage agitator is there. NP is 0.6 in case of anchor agitator. Then density is 1000. N raised to 3 N is 1.25. It is calculated over here. And then sweep dia raised to 5. It is 1.2 raised to 5. So this will give 2.91 kilowatt power. So it is equivalent to the 3.9 HP. Now this is the agitator power. We have not added motor efficiency, then the transmission losses. Basis that the motor HP will be 4.87. Means transmission and efficiency losses overall there are 20 to 30%. So over here 20% considered. Basis that 4.87 and its nearest HP will be 5. So this parameter is the power taken by the agitator. So this agitated power we have to always take along with its volume. So the reaction mass, volume and power exerted by the agitator, that ratio is important. So P, that is called P by V ratio. So we have to put a power. You can use HP as well. HP divided by the volume. So we can get the P by V ratio in HP per unit volume. So that ratio we have to use from the kilo lab batches, and that ratio we have to maintain at plant level as well. All this exercise we are doing for the purpose of only to match the intensity of mixing during unit operation. That will be either reaction, that will be either extraction, that will be either crystallization. Only that much is the purpose. If we match the kilo lab P by V ratio for this calculation, agitator power requirement is important. Volume you know very well. So that ratio we have to match to the plant level as well. But note one thing, this is one of the factor that is considered. Along with there are so many factors, basis that we have to finalize the reactor and its RPM and its agitator type. So after all the other parameter, you can finalize your strategy for the reactor selection, and accordingly if you match everything, then your scale up will get successful. There are very lesser chances to get fail. So friends, this is all about the agitator power calculation, p by phi ratio, and the consideration of scale up